Hello everyone, welcome to the very first video of our O-Level Physics 5054 series. Whether you're just starting out or looking to strengthen your understanding of physics, you have landed in the right place. In this video, we will walk through a complete overview of how the exam papers are structured and what skills you need to succeed, not just to pass, but to understand physics. Physics is the science of how world works, from why objects fall to how electricity powers your phone to what keeps satellites in orbit. Physics explains it all. But to do well in the subject, you need more than just facts. You need to know how to think like a physicist, like how to analyze data, solve problems, and of course, apply concepts in real life scenarios. Today's session is about to understand the paper's structure. Later, we will also decode those confusing command words, break down the assessment objectives, and set the foundation for the rest of this series. So, if you're ready to make physics simpler, cleaner, and even exciting, grab a pen and your notebook, hit the subscribe button, and let's begin. Before you open a single book or dive into whichever your textbook is, or solve your first equation, you need to know exactly how you will be tested. Because let's be real, how you're going to be tested is just as important as what you're learning. O-level physics structure is divided into three main papers. Each paper tests a different skill set. If you approach all the three the same way, you're setting yourself up for confusion. But if you prepare smartly based on what each paper requires, you are going to build confidence and probably score higher. So let's break this down paper by paper. Paper 1 consists of 40 multiple choice questions to be answered in 1 hour. Each question has four options labeled as A, B, C, and D, and only one is correct. You cannot assume two or more options as correct. This paper contributes 30% of your total grade. It's primarily testing your AO1, that is knowledge and understanding. We will discuss about this in later minutes. Just a quick fix here would be that it simply checks your memory, your ability to recognize pattern, and your grasp of scientific laws, definition, unit, and apparatuses. For example, you can see a question paper on the screen. It's from the past paper. The question statement states that which statement about molecules in a solid is correct? Option A. They move freely and rapidly. If anyone here is familiar with kinetic molecular model, then it's very obvious that none of the characteristics are correct. Solid particles are neither free and nor move rapidly. Option B. They are far apart and vibrate. Vibrate is correct for solids, but the first characteristic is wrong as it refers to huge spaces between molecules. That is obviously not correct for solids. Option C. They are close together and vibrate in fixed position. Both mentions the feature of the solid, hence we could consider that C is the correct option. Moving to D, they are randomly arranged. You must go through every option, and D being incorrect sections of belief that C is the right answer. Here, the examiner is testing your conceptual knowledge of particle behavior, a fundamental concept in thermal physics. To solve paper 1 effectively, there are some strategies that you can adopt. Some of them would be practice past paper regularly, not just with the lens to overview the content, but to train your speed and to recognize the pattern. Be wary of the trap options that look nearly correct but are incorrect. Use processes of elimination, that is to cross off obviously the wrong. Use estimation when needed, especially for calculation based MCQs. Exact solving is rarely necessary. Approximating quickly can save time. Our next broken chunk is the question type, that what you will see in the paper. Paper 1 could give you definition based questions like what is the unit for force, or conceptual comparisons like which graph shows the constant acceleration. There could be calculation with simple values. That what is the potential difference if the current is 2 ampere and the resistance is 5 ampere. There could be diagrams with structure, lever, ray patterns, and many more. Lastly, for paper 1 is our time managing strategy. You have just 90 seconds per question. That's quick. If a question is taking too long, flag it and move on. Don't lose momentum. Moving to the next paper, paper 2. It is the theory paper. Paper 2 is the core of your writing assessment, accounting for 50% of your total grade. It's 80-mark paper. You're supposed to solve this paper in 1 hour and 45 minutes. It includes a mix of short answers and structured questions designed to test both your knowledge and application. This paper focuses on Assessment Objective 1 and Assessment Objective 2. Assessment Objective 1 is to recall and understand, and Assessment Objective 2 is to handle the data, your explanation, your prediction, problem solving. For example, a sample question from the past paper says a trolley accelerates down a slope. A graph of velocity time is shown. Calculate the acceleration. You're expected to extract information from the graph, use the correct formula, which would be acceleration is equivalent to change in velocity divided by the time, show working, and include correct units. For clarification, let's walk through another example. A circuit diagram is shown. Explain why the bulb does not light. This question tests your understanding of circuits and asks you to apply knowledge to a new setup, a clear AO2 skill. For paper 2, the question type may include explain, like explain why thermal expansion occurs in solid, or describe the motion of an object with constant speed, or it could be predict the effect of increasing resistance on current. So some tips to ace your paper 2 include must show you're working. Even if your answer is wrong, you can get marks for your method. Use proper units and significant figures. Significant figures are mostly you're going to include two, but better way would be to look how many significant figures are in the question. Practice writing clear explanations. Avoid vague terms like it goes up or it changes. Learn to read data tables and graph accurately. Lastly, is our time management. You have about 1.3 minute per marks. So if a question is worth 5 marks, aim to finish it under 7 minutes. Don't over explain a 2-mark question and don't rush a 6-mark one. Finally, paper 3 or 4, practical or alternative practical. This paper tests your experimental skill, which is known as the AO3 or Assessment Objective 3. You either take paper 3 or paper 4, depending on your school. Paper 3 is the practical paper. It is of 40 marks, and you're supposed to complete your paper in 1 hour and 35 minutes. You carry out real experiments in the lab. You will be asked to take measurements, record data in table, plot graphs, analyze results, identify errors, and suggest improvement. For example, a sample question from past paper says measure the resistance of a wire using a voltmeter and ammeter. Plot a graph of voltage current. You're graded on your accuracy of measurement, your neat graph drawing, your proper labeling of axes, clear trend identification. Moving to the last paper 4, that is alternate to practical. It's 40 marker paper and you're supposed to complete it in 1 hour. No lab is required. Instead, you analyze descriptions of the experiment, ideal for private candidates or school without lab access. For example, a sample question from past paper says a student measures the boiling point of water but records 97 degree instead of 100. Suggest two sources of error. The skill tested in paper 4 are understanding of lab procedures, reading instrument like stopwatch, thermometer, or ammeter, identifying variables, drawing conclusion from experimental data. Some key tips would be learn how to set up standard experiments like Ohm's law, cooling curves, pendulum time. Mass with a balance and volume with a measuring cylinder. For paper 4, practice describing processes step by step. For example, to find density, measure mass with a balance and volume with a measuring cylinder. Memorize sources of error like parallax error, heat loss, reaction time, equipment calibration. So the timing strategy here would be for paper 3, you have roughly 22 minutes per experimental session. And that wraps up our today's complete breakdown of O-level physics 5054 exam structure. We have explored how each paper targets a different skill set, whether it's factual recall, problem solving, or practical application. Understanding the structure is your first step towards mastering the subject. Because once you know how you will be tested, you can study smarter, not just harder. In the next video, we will dive into the actual content of the syllabus, the foundation of everything you will study in physics. We will cover common errors and how to avoid error when working with physical quantities. So make sure you have subscribed, turn on the notification, and get ready to explore physics in a way that finally makes sense. See you in the next session.